Hello student, in this topic we will cover evolution of various type of operating system, how the operating system evolved, what are the generations. So let us discuss the topic. So in this the evolution we will cover up single user single tasking operating system, single user multitasking operating system, multi-user multitasking operating system, real-time operating system, multi-program operating system, distributed operating system, parallel operating system, clustered operating system, and last one is the mobile or handheld operating system. The classification may contain more, such as mainframe systems, etc., network systems. So we will cover up only few of them. So firstly, single user, single tasking operating system. An operating system that allows a single user to log in the system at a time and allows him or her to perform only one task at a time is called single user, single tasking operating system. Example is the DOS. In the DOS, only one user can log in and we will not get command prompt back until the entire process will not get complete. For example, I have a movie file of 700 MB and I am copying that from one location to another location, for example, C drive to D drive, and I have used the run command CP. So when I have typed the command CP and source file name and destination file name, so in that case, I will not get prompt until I will not, the process will not get complete, means copy process will not get complete. So only one task run at a time. Similarly, in Unix terminal or command prompt, only one process can execute at a time, but Unix has the facility to send a process into the background using the ampersand sign at the last of the command. So I am not talking about the Unix. I am giving the example of the simple tasking, single user operating system, that is your MS DOS and POM OS, etc. Single user multitasking operating system. In the single user multitasking system allows only one user to log in the system and it can perform multiple tasks simultaneously. For example, I am the user, I have entered into the system and I can perform the copy, I can listen the song, I can make a C program, etc. So Windows 95 is an example of the single user multitasking operating system. If you have make only a single user account, that is your administrator account in your system, then it will be the single user and you are performing multiple tasks, for example, copying the file, listening the song, watching the movie simultaneously. So your system will be also treated as the single user and multitasking operating system. The example are Microsoft Windows, Unix, Linux, Macintosh, etc. Multi-user multitasking system. If I have configured the network in my system, or I have made up more than one login in my system. For example, I can see I have made up a one administrator user, and second one is by my name, and second one is my colleague name. So when I have started a copying of a file from one location to the another location, and I have switch user. There is a there is a option switch user, and I have switched from one user to the another user, and or I have basically not the log off. I have switched use the switch user. Press the button switch user. Now, as I have the login screen will be again available. So another user or my colleague can enter his login name and password, and he can enter into the system. So more than one user can enter simultaneously. In the another way, if I am talking about the client server version, so this is the server. Suppose that railway reservation server, and there may be more than one client terminal. This is the client terminal C1. This is the C2. This is C3, and this is C4. There are four terminals C1, C2, C3, and C4. All are connected with the console, or we can say server. In terms of Linux or Unix, the server system is known as the console. And these are the maybe intelligent or the dumb terminal which are connected with the server using the high speed lines. So in the railway reservation system, all systems have are the dumb terminals, and they perform all the services or the all computation at the server. So that means C1 is also user C1 user C1 working on the user U1 working on the computer C1, or user U2 is working on the computer C2. All are connected to the server, or we can say console. So this is the another example of the multi-user environment where more than one user can work simultaneously. The example of the multi-user multitasking operating system are the Unix, Linux, virtual memory system VMS, Windows, novel NetWare, mainframe, etc. Real-time operating system. In the real-time operating system, the time matters. That means the work must be performed within the time limit. That time limit basically in the nanosecond, in the millisecond, etc. So here the definition, it works in real-time fashion. The response should be guaranteed within a specific time constant. Otherwise, severe consequences may occur. RTOS has less user interaction, means user cannot interact again and again. Once it has given the task, now the system will perform all the related components or related subtasks. User will not have to interact again and again. Example of are the flight control system, nuclear reactor, medical critical care system, missile defense system, robotics application, microcontroller based home appliances, industrial control system, multimedia application, etc. Example of the real-time operating system are the Linux OS, operating system embedded OSE, Unix, RT Linux, VxWorks, Windows CE, etc. The real-time system is again classified into two types. First one is the hard real-time operating system, and second one is the soft real-time operating system. In case of hard real-time operating system, the time is very much crucial. For example, missile launching system, airspace, aircraft launching system, etc., or nuclear reactor system, where the time limit nanosecond matters. So, coming on the definition, this type of the system are highly restricted to time. Missing of the deadline may have terrible consequences. Example of the hard real-time system are the flight control system, nuclear power reactor system, anti-missile system, etc. In the nanosecond, if a anti-missile system miss a missile, so in that case, that missile can destroy a particular location or geographical area. So time is very much crucial here. The example of the diagram. So event occurs and it must be bind up. It must be bind up in the nanosecond of the time. While in case of soft real-time system, it is a system whose operation is degraded if result is not produced according to the specific timing requirement. Means the output will be not as is should. For example, microcontroller based home appliances, multimedia transmission, reception of networking, telecommunication, mobile network, etc. So time matters, but a certain amount of delay does not affect more. Here you can see in the diagram the time, although the deadline was this one, but the the task was completed after certain time of interval, so it is manageable. There is no harm in such type of systems. For example, if I am working on the home automation system and switch on the my fridge or lights. So if there is a delay of the 1 second or the 1 millisecond, then it doesn't matter due to the network traffic. While in case of hard real time, the time matters a lot. So here is the difference that can be asked during the examination. Differentiate between a hard real time system and soft real time system. Hard real time system, the size of the data files are very small because it has to perform the task within the time limit. The size of the data files may be larger. In this system, the response time in the millisecond or nanosecond. Here, it may be the higher. Peak load performance should be predictable. Means if I will give the this much amount of load, then it will perform the work within the time limit. Here, if there is a delay, that can be accommodated. Safety is a critical issue. Here, safety is also a issue, but less critical. Hard real-time systems are very restrictive. Here, these are the less restrictive. In case of an error in hard real-time system, the computation is rolled back. Entire computation is rolled back. While here, the computation is rolled back to the previous established checkpoints. Not the entire operation will roll back. Only it will roll back to the previous checkpoint. Examples as we have already discussed: satellite launching system, missile launching system, etc. Here, the microwave, washing machines, all the multimedia transmission, etc. Now, coming on the multi-program operating system. To increase the efficiency of the CPU in the olden days, because there was only one program can execute in the by the operating system. So one program is bring up from the secondary device to the primary memory, and when it will get executed, it has to swap out from primary to secondary memory. So during the swap in or the swap out, the processor will not perform any useful work. So to increase the performance, there is a concept brings into the uh, processors, or we can say computers, that is your multi-programming. Means more than one program can resides in the main memory. So these programs are known as the jobs. So this is the concept is known as a multi-programming. Here is the definition. The operating system in which two or more programs are in the memory at the same time and sharing the processor is referred as the multi-programming operating system. In multi-programming operating system, a single processor is shared by the number of processes, means P1, P2, P3, and P4. It increases the CPU utilization by switching between jobs so that the CPU always has one job to get executed. Now, distributed operating system. Distributed systems carries out basically maybe at in the different location. For example, in distributed system, the computation is carried out by the several physical processor in parallel located at the different location. One server is locating at Mumbai, another is in Delhi, third one is Calcutta, fourth one in Chennai. So there are four different computers which are located at the different location, but they are working simultaneously together by sharing the data. So such type of system is known as the distributed system. They are interconnected with the help of the high speed transmission lines so that there should be a least amount of delay. The processor do not share clock and memory. Means when they are when the computers are at different location, then how can they share the clocks or the memory? Because each processor has its own local clock and its own local memory. The processor communicate with another through various communication lines such as high speed buses or telephone lines. This I have already discussed. When system are when process or we can specifically say processors are not on a single motherboard, so those are known as the loosely coupled, not the tightly coupled. In case of tightly coupled, the processor must reside on the single motherboard. Here in distributed systems, the processors are loosely known as the loosely coupled or the distributed because they are not at a one physical location. The processor in distributed system may vary in size and functions. They may include a small microprocessor, workstation, and PC, etc. In parallel system, the computation is carried out by the several physical processors in parallel located on the same motherboard. Here, this is the processor 1, this is the processor 2, this is the processor N, and they are existing on the same motherboard. That means they may share the buses and share the memory. These processor handle a separate part of overall task. There may be a bigger query. That query may be split it into the smaller part, and each processor may execute its part of that query. These processors share the computer bus, clock, sometimes memory, and the peripheral devices. Since resides on a single motherboard, that's why these are known as the tightly coupled system. In parallel processing, commonly used to perform complex tasks and computation, the data scientist will commonly make use of the parallel processing for the computation and data incentive tasks. Now, parallel systems are again classified into two types. First one is the symmetric and second one is the asymmetric. So firstly, I am going to discuss about the asymmetric. As its name shows, asymmetric means all processors are not similar. Means there is a one processor which is controlling the all remaining processor. For example, this is a processor P1, or I am saying not saying it's processor P1, it is master processor PM, and there are number of another processor P1, P2, P3, and P4. There are four processors P1, P2, P3, and P4. These are the four sub-processors. The master processor will decide which part of the query or the process has to be performed by the processor P1, which part will be executed by the processor P2, which part by the processor P3, and which part by the processor P4. So processor PM, that is the master processor, will decide which task will be performed by the which processor. So this is just like the master slave concept. Master slave concept means there is a master processor and the rest are the slave processors. All slave processors are controlled by the master processor. While in case of symmetric multiprocessing, there is no difference between the processors. All processors work or perform the task simultaneously. For example, here is the definition. The most common system uses the symmetric multiprocessing in which each processor performs all tasks within the operating system. SMP means that all processors are paired, no master-slave relationship exists between the processor. So, whenever a processor is performing a task, for example, here we can I can depict better than a diagram. Suppose that this is a processor P1, this is the processor P2, and next one is the processor P3, and this is the processor P4. So there are four processor, and this is the memory. This is the memory location. So processor P1 pick up a job from the whatever it has to perform, or whatever the task started by the operating system. P1 will pick up a task, then P2 will also pick up, then P3 and P4. Suppose that P1 has been bind up one of the tasks, it will request to the operating system to assign the another task. So all processor has equal priority. There is no master slave processor, no such as in the asymmetric, the master will assign a task, otherwise it will simply sit ideal. So in the symmetric multiprocessing system, all processor have the equal priority, equal rights, and they pick up the job from the pool one by one. Clustered operating system. The cluster computers shares the storage and are closely linked by the local area network LAN for all the faster interconnection. Here, this is a server, and they are number of the computers, they are connected through the a group of computers. So a computer is connected through a group of computers. So this is a cluster. Cluster system combines the best feature of the both distributed OS and multiprocessor system. Means this has the single its own processor, it has its own processor, but they are connected through the high speed lines and located within a geographical location. That means they are not situated, one is in the Mumbai, another one in the Delhi, and third one is in the Chennai, and so on. They are located within a specific geographical location. So such type of the systems are known as the cluster systems. Last one is the handheld or the mobile operating system. We are using nowadays mobile devices such as palm top, or uh, we can say mobile phone, or the uh, various devices. For example, wristwatches, smartphones, etc. PDA, tablets. So all are the hand 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 systems, and these systems are all known as the mobile operating system. These devices have the lower speed processor and less memory. They were designed to use less memory and acquire fewer resources only. The example of the some of the such type of operating system are the Symbian, Windows Mobile, Android, iPhone, BlackBerry, Linux, Palm OS, etc. So these are known as the handheld system. Now, the question that we should know difference between the different type of the Intel processors, because we have listened the term Pentium 1 series, Pentium 2, Pentium 3, Pentium 4, Celeron, Core to do, Dual Core, and so on. Nowadays, we are using the i3, i5, i7, i9 also. So, what is the difference? That we must be aware during the examination. Such type of question may be asked: what is the difference between these processor models? So, this is from my side. Thank you.